Okay, so this last part is talking about predator-prey relationships, okay? And so it says Thomas Austin, he was an Englishman, he took rabbits into Australia, they reproduced like rabbits, and you ended up with huge amounts of the population, and it asks what are the consequences. So question 18 is really no big deal, they can just talk about different consequences, the rabbits eat the crops, whatever. Okay, and then 19, it says that they introduced foxes to the population. Okay, and so foxes are a predator of the rabbit. So on that graph for 19, they should be graphing the rabbit population. So originally, when Thomas Austin added these rabbits, they would be growing exponentially because there was nothing to limit their growth. And then when they added the foxes, they should start to see a carrying capacity and maybe even go down a little bit. So that's what they should be graphing for 19. And then 20, it says, what do you suppose will happen to red fox populations? And you're supposed to add a curve for the predator. And so if you look at the predator for red fox, as the rabbit population went up, then we had the predator introduced to this small number. Well, as the rabbit populations go up, so do the predator populations. But as they start to pick off the rabbits, then the predator populations should start to level out too and go back down. So you sort of should see something like that on the graph under 19. And then 21 says, as the red fox populations increase, what happens to the rabbit populations and vice versa. And so what you should predict, so for the next graph, if the rabbit populations go up like this, and then the fox populations go up because the rabbit populations are going up, and so as the fox populations go up, the rabbit populations start to go down, and as the rabbit populations start to go down, then the fox populations have to go down, and as the foxes go down, the rabbits can grow, so they start to go back up, and as they go back up, then the fox follows, and so on. You see the idea, you get this reciprocating curve like that, and it's slightly delayed in the predator, so that's what should be number 21. Okay, and they're going to share these graphs on their whiteboards. And then they're going to use the actual predator-prey model. This is the Lotka-Volterra model, and you can see in the model that it's the exact same. It's the, and that D should be delta N over delta T equals Rn. So it's just like our exponential growth equation, but then they add in this ANP, which is the predator, which is going to limit the growth. Okay, and same thing with the predator. The predator is doing an Rn also, except we call it Rp, but theirs is based on how many resources they get, that BNP. Okay. And so there's a simulation on the computer, which I'm going to show you. I'm going to stop this and I will show you the simulation.